You there. Yeah, you. Want a line follow? As you might be thinking from my title, this is an advanced line follower, so you might be thinking it's for some of my more experienced viewers, but in reality that's not true at all. It's not that complicated. It's just that it has some math, and the math should be easy enough to understand. I'll explain it at the end. Anyway, let's jump into the program. So to start off, we're going to have 5 different variables. One for speed. I'll explain what that is later on. But for now, just think of it as the the speed that you want the robot to be going at the exact center of the black and white line, the target. Then you're going to want to get an average variable. That's for the average light value. Then you're going to want to grab a KP, because since this is advanced, we're going to be scaling our calculations with KP value. We're also going to grab a light sensor port, and when we turn this into a my block, all the parameters are going to be plugged into this, and we have one last one, and that's going to be called a left or right variable. It's in logic, unlike the other ones. They're all right, by the way. They're not read. I don't have that right now. I'm gonna create it. Yeah, and those are the variables to start off. And of course, just for convenience, we're gonna start off by resetting the light sensor port. Calibrate reflected light intensity, reset. And the cool thing about this is that we don't need to input a port. It automatically does it for whichever light sensor there is plugged in, which for my robot is 3 right now. And then we're going to grab out a loop. Because we want this to repeat over and over. We're also going to grab out a switch and set it to logic. And that's where we'll be taking this right and / left logic variable, set it to read numeric, and plug it in right here. Whoops. Read logic. So what the point of the switch is that if the user decides to input the direction as the right side of the line, then it's gonna have execute this code, and if it's on the left side, it should be on this. It should execute this code. So let's get to that. And now we're gonna have to start using the rest of our variables. And the reason we use variables in programming as opposed to just writing the numbers is that if I have to change a value, I only have to change it once over at the beginning instead of changing it like 10 or 15 times when I'm using it in the program. So we'll grab out a speed, we'll grab out average, we'll grab out KP, and we're also going to have the light sensor current reading that's measuring, compare reflected light intensity, measure reflected light intensity, set it to wired, and we'll grab out the light sensor port, read numeric, and now we'll start off our calculation. So for the sake of programming convenience, instead of just using more than one operation, instead of using multiple operations, I'll use an advanced operation, which allows us to accomplish multiple operations into a single block. And at the end, we'll also grab out a move tank, set that to on. Now this will be your, select whichever port you need, which happens to be B for my robot, and then this will be your right motor, which happens to be C for my bot. We're gonna grab another one of these. Or wait, yeah, we'll grab another one of these. Now the equation, we're gonna put it into here. I'll explain why it is what it is in just a second, but it's D minus A minus B times KP, times C, and put it all in brackets neatly. And we'll copy the exact same thing here and put it into here, except with one slight difference. And that's just going to be that this is going to be the plus sign, and I'll also explain why that is in just a moment. So we'll put this right into the A value of both of the math blocks, and then the average should be plugged into the B value of both the math blocks. The KP should be put into the C values, and lastly, the speed should be put into the D value for both of the math blocks. Now we just take out the equations from each of the math blocks and plug them into the respective motors. And so now I'll explain as to why this works. Now this is of course assuming that we're working, that the robot is following along the right side of the line. So I'll just grab out a sketchpad here. This is a drawing I had open in a previous video. Remember from our basic line following, all that we were doing before is that saying if the robot is sensing white, so pretend the cursor is the bot, it should be sensing a very high value, and it should turn more left. Now that's a fixed value, which will always be 40 versus 30, or 30 versus 40 if it's sensing black. But what you should be doing to get the most accurate and the smoothest turns is the closer it's towards this target value, the less of a correction it has to make, and the farther it is, like all the way here or dead center in the black, the sharper of a correction it needs to make. So all we're doing is that, let's say we have the speed at 50%, 50, exactly along the target. It should be going at 50 power. Well, all we're doing is that we're getting an error value. So whatever the robot is sensing at the moment, let's say it's sensing 60 at the white, minus its target. So let's say this is 34, the average, and that's just 26. So it's adding 26% to the C motor, and it's subtracting that value from the B motor, which is the left. So it's making the robot turn left. That's all it's making it do. And how much of a correction is made is multiplied by the KP value. So assuming that the KP value is 1, it's subtracting and adding exactly 26. But if you make it 0.5, for example, it makes that correction by only 13. And that's essentially how it works. Now, if you wanted to follow the left side of the line, it shouldn't be that complicated. All we're doing is that we're switching around the plus and minus signs for the respective motors. So let's just do that right now. So we're just gonna copy paste this huge chunk of code and do the exact, and then we're doing the exact same thing for the bottom side of the loop, the false side, except we're switching around the power symbols. So we can do that simply by putting this math block equation into motor B and the first one into motor C. Now, if you do the math in your head, you should be able to figure out that it's making corrections in the opposite direction. Now let's make this huge piece of code into my block. So select the entire program and then go to Tools, My Block Builder, and we can give it an appropriate name called Advanced Line Following. And then we'll put a symbol for the light sensor. And we're going to add 5 different parameters, one for each of these. So I'll go ahead and do that right now. The first one we'll call normal speed. And we'll put that as the vertical slider for the power. And we'll give it this icon, the power symbol. We'll call the second one the average. And I'll leave that for this, but the minimum will be 0, of course, and the maximum will be 100. The parameter icon should be simple, because that's just what makes sense to me, at least. KP, I'll leave it at the same icon, and I'll just call it that. For the left light sensor port, I'll just call it that, the light sensor port. And I'll grab out the port symbol, parameter icon. I'll leave it something simple like this, left or right, right or left, same thing. Finish. And now, if we look at our advanced line follow, it got compressed into this nice my block. If you ever want to see the huge program again, if you want to edit it, just double click, and wow, right there. Now, before we actually run the program and show it to you, we need to review a few more things, and one of those things is that we actually need to plug in the parameters for this. So I'll do that right now. The light sensor port and the light sensor port variable. This is what I was talking about earlier when I said we need to plug the parameters right into the variables. Another one of those things is that we need to take this chunk of code out of the loop, and the reason for that is well, you might find it convenient, but just for general use, if you want it, you need to be able to set your own exit case for the loop, whatever that may be. And so instead of that already being written in the my block, I wanted to leave it kind of open-ended for you guys. So if we take that out of the loop and just put it back in there, there, got it. Now we can set the loop to whatever, the exit case to whatever we want. All we needed to do is put the my block inside of a loop and then set the exit case to whatever we like. I'll just set it to a time and give it about 8 seconds. And before I show you the program recording of it, I want you to see the light value, and as I've set it to 35, watch as it makes its corrections. Oh, and I would recommend keeping the KP value at 0.31. That seems to work best for my robot. And I'll keep the speed at 0 just to show you, since my light sensor, my lines on the paper isn't exactly printed. It's kind of sharpied. Anyway, download and run. Let's see what happens. It should be going towards 35. And yep, it's going towards 39. It stopped there. And if you want to correct that, all you need to do is make the KP value slightly larger. Let's try 0.38. And it's going down slightly, making larger corrections, and 32. Anyway, you have to experiment with that. I can't necessarily tell you what it'll be, the KP value, but if you fine tune it just right, it should work consistently, and it'll be especially helpful for an FLL bot. Hope you guys loved watching that video, and if you like my channel, remember to subscribe and hit that notification bell button. See ya for next week's tutorial. Bye!